This is like a warm-up before we get to the actual handout that I give you, all right? So quickly, right here, what does it say? X is what? Less than 3. Okay, so what do? We go to the number 3, and are we going to put an open dot or a closed dot? Open dot. So if you're like, oh man, I don't remember this stuff, yeah, go ahead and copy it down, but I don't recommend it. If you already know what I'm doing, you don't have to copy this down. So it's an open dot, and is it to the left or to the right? To the left. So why is that? That's because it says less than. Less than is always to the left. Greater than is always to the right, right? Okay. Anyway, number 2, it says write the inequality of the following graphs. Okay, how about this guy? Is it going to be less than symbol or a greater than symbol? Obviously what? Greater than. So it's going to be x is greater than. Now, is it greater than or equal to, or is it just greater than? Greater than or equal to. Now, how do we know that? Because it's a solid dot. A solid dot produces a solid line underneath your inequality. Okay, and it is going to the right. That's why it's greater than. And what value are we starting at? We're starting at -2. So that is the inequality. X is greater than or equal to -2. Done. Moving on. How about this guy right here? X is what? Less than. Okay. Is it less than or equal to, or just less than? Just less than, right? It's not a solid dot, so you're not going to have a solid line underneath it. Okay, less than what? -2.5. That's good. All right, so -2.5. So that's just a little warm-up. I didn't expect you to copy it down. It's just a little warm-up for what we're about to do. Here's the handout that we're doing, and here's the actual class opener that I want you guys to do. So again, I recommend getting your x to the left side. It's easier to graph if you do get the x to the left side. So let's move that 3x over to the other side by doing the opposite, which is subtracting 3x. What you do to one side, you do to the other side, subtract 3x. And rewrite what you have. 2 take away 3, it's going to be a -1. And of course, we're talking about x's. And let's bring down everything else. So the -4, the greater than symbol, and the 7. So that's our new inequality with the variable on the left side. Let's get that variable by itself. So I'm going to get rid of the -4 by doing the opposite, +4. What I do to one side, I do to the other side. My new inequality will be -1x is greater than 11. My final step will be to get rid of this multiplication of -1 by doing the opposite, dividing by -1, and you'll get x is less than -11. Perfect. All right, let's move on to today's notes. Okay, compound inequalities. So what does compound mean? I mean, just in general, compound. If you have a, yeah, what is that? I know you're putting your something together. There you go. A compound inequality is putting two inequalities together. All right. Now, when we talk about two inequalities together, they might be written together, or they might be separate with the word or. Okay. So it could be written together, or it could be separate with the word or. So let's graph some compound inequalities. So this is technically a compound inequality because there's a word or between it, but it's really just like graphing two inequalities on one number line. Okay, so let's all go to this one, and let's graph x is less than -3. So we go to -3, it's an open dot, and less than is to the left. Ta-da, easy peasy. It's like free points, right? On the quiz or test Friday. The other one, x is greater than or equal to 1. Okay, so go to 1. The or equal to means that it's solid, and greater than is to the right. So let's understand this, guys. When there's the word or, when the word or is there, that means that it's either going that way or that way. The areas are apart. Does that make sense? The word or implies that it's going that way or that way. Okay, now if you have something that's together, it's not going to be the word or. Okay, so or, it's either going that way or that way. Let's go to the next one here. Now this one is a compound inequality, and it's written together. So obviously there is no word or that's separating them. So the areas, when we graph them, are going to be together. It's logical, right? I mean, up here, the word or implies that they're apart. Right here, it's together. So when I graph it, it's going to be together. So how do I graph this? Well, I think this part, if I just block this out, that's really easy to graph, right? The x is less than 1. Let's graph that. X is less than 1. So we're going to put an open dot at 1. Less than is to the left. Let's just leave a small arrow for now. And then let's move that box out of the way. And now let's look at the other part, okay? That's why it's called a compound inequality. It's two inequalities written together with the x in the middle. Now here's the problem here. You have to look at it in terms of x. So what does this say in terms of x? X is what compared to -2? What does it say? X is greater than or equal to -2. Does that make sense? Even though this is a less than or equal to symbol, that's why I say always write the x on the left side. If you're reading it backwards, you got to say x is greater than or equal to -2. So go to -2, put a solid dot at -2, and greater than or equal to is going this way. Okay. You could draw it like that, but I recommend converting those arrows to just a solid line that's connected. So that is the graph of the compound, whoops, yeah, that's the graph of the compound inequality. -2 less than or equal to x less than or equal to 1. What do you guys think? Okay, so once again, the word or, if two inequalities are separate with the word or, obviously the areas are going to be separate, going that way or that way. But if the compound inequality is written together with the x in the middle, then you know your areas are going to be together right here. Okay. Now, what does this really mean, right? Like on a graph, you always want to represent your x values. And right here, x has to be less than 1. Well, could it be 0? Yeah. Could it be -1? Yeah. Could it be -2? Yes. Could it be -3? No. Why not? Because x, in addition to having to be less than 1, it also has to be greater than or equal to -2. Right? So -3 is not greater than or equal to -2. So that's this space right here. So the graph is just representing all the possible x values in this compound inequality. Let's move on. So we have some notes here. Important. If the areas of the inequality are apart, you must write the inequality apart with the word or. But if the areas of the inequality are closed, pointing towards each other, then we must write the inequalities together with x in the middle, the smaller number on the left side, and the bigger number on the right side. So let's start with an easy one. Let's put a open dot at -3, and let's make it go to the left. And let's put a closed dot at 0. Let's make it go to the right. So if I tell you, write a compound inequality representing this graph, how are you going to write it? Anybody? Let's begin with this question. Are the areas together or apart? Apart. So you're going to just write them as two separate inequalities, separated with the word or. Remember, if it's going this way or this way, right? Or implies that they're apart. So all you got to do is just write this inequality, write that inequality, put the word or right between them, right? So let's write down the first inequality that we see right here. That's going to be x is what? Less than -3, okay? And then we're going to put the word or, and then let's do the other one. What does the other one say? X is greater than or equal to 0. And notice I put the solid line because that's a solid dot. So if the areas are apart, you're going to write two inequalities separate with the word or, okay? Now, let's do a different example where the areas are together. So let's do, let's put a dot at -2. Let's put a solid dot at -2. Let's put an open dot at 3. So this is like a type of question that you might see on the quiz or test where I give you the graph and I tell you, write down the compound inequality that's represented with this graph. So if you read the above notes, it says that if the areas are together, you're going to have to write it as a compound inequality together, right? And it's really easy to do, especially if you have the number line right in front of you, because you put the smaller number on the left side, that's obviously -2. You put the bigger number on the right side, that's obviously 3. And you put the x right in the middle, okay? And now all you have to do is fill in the inequality symbols. So when we say x is what compared to 3? It's going to the left. X is what compared to 3? less than. So you put the less than symbol. And when we say x is what compared to negative 2? Greater than, which means that it has to open up. The alligator wants to eat the x, the greater value. So if x is greater than negative 2, it has to open up to the x. And the or equal to means a solid dot. Okay? And I'll be honest with you, there's a easier trick. Whenever the areas are together and you put the smaller number on this side and the smaller number on that side, you're always going to have them opening up that way. Always. It's always going to be less than symbols. They're always going to be opening up to the right. Okay? So, any questions so far? No? Let's go up here. So that's graphing compound inequalities and writing compound inequalities from the graph. Let's go to solving compound inequalities. Okay, so how do we solve a compound inequality? It's exactly the same as solving a regular inequality, but instead of getting x by itself on one side, you want to get x by itself in the middle, right? Now, if you did have two that were separate with the word or, you just solve both, get two answers, and keep the word or between them. Okay, but right here it's a compound inequality that's written all together. So let's get x by itself in the middle. So if you're kind of confused with that, you could just ignore this part of it and just, what would you do right there? You would add 4, right? Now, because it's a compound inequality, you don't just do plus 4 there and plus 4 there. It's whatever you do to the middle, you must do to both outside sides. Okay, so you want to get x by itself in the middle, and whatever you do to the middle, you have to do both outside sides. All right, so you added 4 to get rid of that minus 4. That means you have to add 4 up on both of the outsides. So let's rewrite our new compound inequality that's a little bit nicer. That's going to say negative 4 is less than or equal to 2x, which is less than 2. What's my final step right here to get the x by itself in the middle? Divide by 2. So we're going to divide by 2, divide by 2, divide by 2. Whatever you do to the middle, you do to both outside sides, right? So what's our compound inequality answer going to be? Negative 2 is less than or equal to x, which is less than 1. That's our compound inequality answer to the compound inequality equation. And if they ask you to graph it, it's pretty simple. We know that this is written all together, so the areas are going to have to be together. We know that the negative 2 is going to have a solid dot because it has a solid line underneath it. And we know that the 1 is going to have an open dot because it does not have a solid line underneath it. Now you could think of the inequalities, but if you already know the fact that if it's written together, it's going to be an area that's together, then you could just connect the areas like this. Right? Or you could have said, okay, let me read it. X is less than 1. Oh, here's 1, less than's that way. X is greater than negative 2, greater than's that way. If it's written together, it's going to be an area that's together. If it's separate with the word or, it's going to be separated on the graph, going in opposite directions. So right here, let's solve and graph this compound inequality, which is really just like doing two simple problems. The word or in between it just means that when you get your two answers, keep the word or in between it. So on the first equation, I would subtract 8. I'll have a negative 2x that comes down, a less than symbol, and a negative 6 on this side. What's my final step? Divide by negative 2. And if you divide by a negative on an inequality, what must we do? Flip the inequality symbol. So I'm going to have x is greater than 3. That's one answer. This word or needs to come down because it has to be both answers put together with the word or in between it. Let's solve the other one. The other one, okay, so add 2 here, add 2 there. We end up with 5x is less than 10. Final step is to divide by 5. Divide by 5. So our other answer is x is less than 2. So here's our compound inequality answer, separate with the word or, which means that it's really easy to graph because which direction are these guys going in? Are they pointing towards each other or apart? Apart. Okay, so let's go to the 3, put an open dot at 3. Let's go to the 2, put an open dot at 2. So this guy right here, x is greater than 3. Greater is to the right. X is less than 2. less than is to the left. Now, obviously, that's kind of pointless to even think that through, because if it's a part with the word or, it has to be a part. If it were a compound inequality written together, then it would have to be an area together. Now, here's a curveball that they might throw at you. The word and. Or means apart, and means together. Okay? So let's solve this guy. Plus 4 plus 4. We'll have 2c is greater than negative 2. Final step will be to divide by positive 2. We're not flipping anything. Final answer is, or final inequality is, c is greater than negative 1. Okay, now we have the word and, not the word or. Or means apart, and is technically together. Okay, let's do the other one. Minus 1, minus 1. We have 3c is less than 12. And for my final step, to get rid of the multiplication of 3 in front of the c, I would have to divide by 3 and divide by 3, which means c is less than 4. So we have this answer, and the word and between it, which means that it should be written together. So if we want to write it together, we could write it as a compound inequality by putting the smaller value on the left side and the bigger value on the right side, and putting the x in the middle with the appropriate inequality symbols. So if I take a look at this inequality, the c is greater than negative 1. I shouldn't have put x, I should have put c. Let's change that. C. Doesn't really matter. C. Okay, so when you compare c and negative 1, c is greater than negative 1, so it has to open up to the c. And right here, c and 4, it has to open up to the 4. So it opens up to the 4. So there's my compound inequality written together instead of having that word and. Okay. Now let's graph it. Negative 1. It's going to be an open dot at negative 1. It's going to be a open dot at 4. There is no 4. Okay. Let's do an open dot right there. Let's put a 4 right there. And these areas are together. Now finally, let's get to the absolute value inequalities. Absolute value inequalities. All right, so we've already solved absolute value equations. And how did we do that? We first isolated the absolute value, and then we did a positive situation and a negative situation, right? And then we got two answers, okay? How do we do the positive situation? After it's isolated, you write it exactly the way it is without the absolute values. And the negative situation was all about changing the sign of the right side, right? But since we have an inequality here, not an equal sign, you're going to change the sign of the right side and change the inequality on the negative situation. Okay, so let's first isolate the absolute value. How do I isolate that absolute value? What do I do to get that absolute value? Plus 7. Plus 7. I have absolute value of 2x plus 2 is less than or equal to 2. All right, now it's isolated. That means now I'm ready for the positive situation and the negative situation with a squiggly line in between it. So the positive situation is writing it exactly the way it is. 2x plus 2 is less than or equal to 2. The negative situation is the same exact thing as this guy, but you change this to a negative and you flip that inequality symbol. Okay? Before we had an equal sign. If you flip an equal sign, it still says equal, right? Right now that it's an inequality, on the negative situation, you have to flip the inequality and change the sign. So what we really have is 2x plus 2 is greater than or equal to negative 2. Maybe I should do this in a different color because that's what changed on the negative situation. Now let's solve for both. So on the left side, we end up with 2x is less than 0, less than or equal to 0. And my final step would be to divide by 2 and divide by 2, which means x is less than or equal to 0. Now in the negative situation, we're going to subtract 2, rewrite what we have. 2x is greater than or equal to negative 4, which means my final step to get rid of the multiplication of x, or multiplication of 2 in front of x, would be to do the opposite, divide by 2, and you'd get x is greater than or equal to negative 2. We did not flip the inequality symbol because we divided by positive 2. We didn't divide by a negative on our last step. So we have our two answers, but we need to write it either as a compound inequality separate with the word or together with the x in the middle, the smaller value on the left side and the bigger value on the right side. How do we determine if it has to be written together or apart with the word or? We have to look at a number line. Okay, so it's all related. Let's do a quick number line sketch. Let's put the 0 right here. 1, 2, oh wait a minute, it's negative 2. Negative 1, negative 2, negative 3. It's going to be a closed dot at 0. This guy right here is going to be a closed dot at 0. And it's going which way? To the left or to the right? To the left. And let's go to this guy over here. X is greater than or equal to negative 2. Go to negative 2, put a solid dot right there. And what do? To the right, because it's greater than. So here is my graph. If they ask you to graph, it's going to be that area together. But more importantly, we graph this to be able to know how to represent our answer. Since the areas are together, we have to write it together with the x in the middle, the smaller value on the left side, the bigger value on the right side, and then putting the appropriate inequality symbols, which we said are going to be less than symbols always, because it's written together. So this is your final answer right there, compound inequality answer.